Hello students, welcome to Diksha Karnataka YouTube channel. In this video, I'm going to discuss top 30 questions in current electricity. Okay, so this is high weightage chapter for KCET 2024. Okay, so in this chapter, at least they will ask 5 to 6 questions. Just try to solve these questions. Okay, top 30 questions. If you are able to solve this top 30 question, so definitely you will be able to counter these kind of question in KCET. Okay, yeah, let us start. Question number 1. For a given electric current, the drift velocity of conduction electrons in a copper wire is Vd and their mobility is mu when the current is increased at constant temperature. Okay, so we know that drift velocity Vd is equal to I divided by N into E into A, right? I is current, right? N is number density, electrons number density. E is charge of the electron, A is area, right? Area of cross section of the wire. And we know that mobility mu equal to Vd divided by E, right? Mobility mu equal to Vd divided by E. And also we know that drift velocity Vd equal to E into capital E into tau divided by m, right? Okay, so let's check each options. Okay, so we just wrote down all the formulas of drift velocity, okay, and mobility. Let's check each option. Option A, Vd remains the same, mu increases. Okay, so as the value of current increases, mu d will also be increases, sorry, Vd will also be increases, that is drift velocity will also be increases, right? So what is the meaning of increasing current, right? Here the increasing current means the more number of electrons flowing through the cross sectional area, right? That is rate of flow of charge increases, right? Rate of flow of charge increases. If rate of flow of charge increases, drift velocity will also be increases, right? If current increases at a constant temperature. Okay, mobility increases. Let's see here, substitute Vd to this equation. Now mu equal to mobility equal to here E into tau divided by m whole divided by E. Now E will get cancelled. Mu equal to E into tau divided by m. Now mobility depends on the current. No, right? Mobility does not depend on the current, isn't it? So mobility remains same, right? It remains same. So the first option is wrong. Second option, Vd decreases, wrong. Third option, Vd remains the same, wrong. Fourth option, Vd increases, correct. Mu remains the same, correct. So option D is the correct answer. Okay, yeah. Next question, question number 2, right? 10 identical cells, each of EMF 2 volt and internal resistance 1 ohm are connected in series with 2 cells wrongly connected. Okay, a resistor of 10 ohm is connected to the combination. What is the current through the resistor? Okay, let us draw the diagram. Here 10 EMFs, right? Ten EMFs. Okay, it is connected to a external resistor R. Okay, this is the switch is closed, right? So EMF E R, identical EMF, right? Identical cells, right? So ER and so on. Okay, understood? And then here each EMF is 2 volt, right? Isn't it? Each EMF is 2 volt and internal resistance is 1 ohm. All of them are in series, right? Isn't it? Two cells connected wrongly. Okay, two cells connected wrongly. Then resistor here R equal to 10 ohm, right? To this combination we need to find current through the resistor, right? Okay, so current through the resistor I equal to E equivalent divided by R equivalent, right? E equivalent divided by R equivalent. See, all of them are in series, right? All of them are in series. So current in the series circuit does not change, right? Or does not divide, isn't it? So current through this all cell and resistor is same, right? Isn't it? Okay. So let us find E equivalent, right? So two cells are connected wrongly, right? So E equivalent is equal to, there are 8 cells connected in series, right? Isn't it? Two cells are connected wrongly, isn't it? That is, it is connected ulta, right? So E equivalent is equal to 8 cells into EMF of the cell 2 volt minus, here the polarity changes, right? Because it is connected wrongly. So minus, two cells are connected wrongly, so 2 into 2 volt. So E equivalent is equal to 16 minus 4, that is 12 volt, right? 16 minus 4, that is 12 volt. So what is the R equivalent? R equivalent is equal to, internal resistance is 1 ohm, there are 10 cells, right? So 10 ohm plus 10 ohm, 20 ohm, right? Now current through the resistor, E equivalent, that is 12 volt, right? 12 volt divided by R equivalent is 20, right? Solve this, you will get I equal to, here 12 by 20, right? 12 by 20 is 0.6, right? Here 4 3s are 12, 4 5s are 20. So 3 by 5 is 0.6. So 0.6 ampere. So the correct option is B. Okay. Yeah. Next question. Question number 3. The equivalent resistance between the points A and B in the following circuit. See, this is the infinite ladder circuit, right? Isn't it? Infinity, infinity. Infinite ladder circuit, isn't it? We need to find the equivalent resistance between A and B, isn't it? Okay. So this is infinite ladder circuit, right? Let's say X is the equivalent resistance between A and B, right? X is the equivalent resistance between A and B. Okay. I can also consider X as the equivalent resistance between C and D, right? I can also consider X as the equivalent resistance between C and D, right? Why? Because it is infinite ladder, right? It is infinite ladder. So here the equivalent resistance between C and D is almost equal to equivalent resistance between A and B, right? Because it's infinite ladder, right? Isn't it? Okay. So here I can redraw this circuit diagram, right? So this is A, right? Resistance 2 ohm. Here resistance 2 ohm. This is point B, resistance 2 ohm, and this 2 ohm connected in parallel with X, right? Equivalent resistance between C and D, right? So now solve. Here X and 2, these two are in parallel, then this whole thing is in series with 2 ohm and 2 ohm, right? Okay. So what is the resistance between 2 ohm and X? Here what is the resistance, equivalent resistance between these two, right? These 2 points. So that will be here, let's say R dash. Okay, R dash is equal to 2x divided by 2 plus x, right? Because these two are in parallel, right? For parallel, if two resistors are in parallel, then equivalent resistance between them is R1 into R2 divided by R1 plus R2, right? So this is 2x divided by 2 plus x, right? Now R dash is in series with 2 ohm and 2 ohm, right? Anyway, 2 ohm and 2 ohm, these two are in series, right? So this is 4 ohm, right? So x is equal to 4 plus 2x divided by 2 plus x. Okay. So now take LCM. Here take LCM and then take 2 plus x to the other side. 2 plus x into x is equal to 4 plus 2x, right? Sorry, 4 into 2 plus x plus 2x, right? Now 2x plus x square equal to 8 plus 4x plus 2x. Now 2x will get cancelled, right? So x square minus 4x minus 8 equal to 0. Now this is quadratic equation, right? Solve. Here you know the formula, x equal to minus b plus or minus root of b square minus 4ac by 2a, right? Here a equal to 1, b equal to minus 4, c equal to minus 8. So now x equal to minus b plus or minus root of b square minus 4ac divided by 2a. Now x equal to 4 plus or minus root of 16 plus 32, that is 48, right? 48 divided by 2, right? 48, root of 48 is almost equal to 7, right? Because root 49 is 7, right? So it is root 48. So root 48 is almost equal to 7, right? That is 6.9 something, right? So I can consider it as a 7. So here this will be 4 plus or minus 7 divided by 2, right? So you cannot consider 4 minus 7 because resistance cannot be in negative, right? So it is 4 plus 7 by 2. 4 plus 7 by 2 is 11 by 2. 11 by 2 is 5.5. So x is almost equal to 5.5. X is almost equal to 5.5. 5.5 ohm. Okay. 5.5 ohm. So the correct option is A. Okay. Next question. Question number 4. The resistance of a carbon resistor is 4.7 kilo ohm, 5%. Here 5% is plus or minus 5%, that is tolerance. Okay. The color of the third band is. Okay, we need to find the color of the third band, right? So that is, here this is the carbon resistor, right? So there are 4 bands. Isn't it? A, B, C and D. C is the third band, right? So how do you find the resistance of this resistor? A into B, sorry, AB into C, and D is the tolerance, right? D is the tolerance. Tolerance, right? Isn't it? D is the tolerance. Okay, so here 4.7 kilo ohm, right? 4.7 kilo ohm and plus or minus 5% tolerance. So this is for gold, right? So this is for gold. Now I can write 4.7 kilo ohm as 47 into 10 to the power 2 ohm, right? 47 into 10 to the power 7 ohm, right? So here the third band is C, right? That is 10 to the power 2, right? 10 to the power 2. So here 10 to the power 2 represents red, right? 10 to the power 2 represents red. So the correct option is A. Okay. Simple one, right? So you should remember the tables, right? You should remember the tables, every color, right? Every colors, and then the numbers, right? The number which represents every color. Yeah. Next question, question number 5. The 4 bands of a color coded resistor are of the gray, red, here this is gray, G-R-E-Y, gray, red, gold and gold. The value of the resistance of the resistor. Okay. So here the first one is gray, right? Isn't it? For gray it is 8, right? 8. You know, right? There are 4 colors, 4 bands. So how do you represent the resistance? Here AB, how do you write the resistance using those 4 bands? 4 bands are A, B, C, D. So AB into C and D is the tolerance, right? D is the tolerance, isn't it? So A is 8, that is gray, For red, it is 2, right? And C is gold, right? That is 10 to the power minus 1, and D is plus or minus 5%, right? So 82 into 10 to the power minus 1 is 8.2 ohm, and plus or minus 5% tolerance. So the correct option is B. Okay. Yeah. Next question. Question number 6. A wire of resistance R is connected across a cell of EMF E. Internal resistance R. The current through the circuit is I. In time t, the work done by the battery to establish the current I is. Okay, here everybody knows the work done by the battery, W is equal to charge flown through the battery into potential difference, right? Potential difference of the battery, or potential difference across the battery, right? So what is Q? Q is charge, right? Charge flown through the battery, right? So that is current I into T, right? We know that current I equal to Q divided by T. So Q equal to I into T. Okay. Now work done is equal to, here Q is I into T into V. V is E. So I can write work done W equal to EIT. EIT. So the correct option is D. See here, they are asking work done by the battery to establish the current I, right? So it cannot be I square RT and E square T divided by R. Okay. Understood? So it cannot be I square RT, E square T divided by R. I square RT is here the heat developed in the resistor, right? Isn't it? Right? So both are incorrect. A and C both are incorrect. So D is the correct answer, right? B is also incorrect. IRT. That is not the energy equation, right? Yeah. Next question, question number 7. 10 identical cells, each of potential E and internal resistance R, connected in series to form a closed circuit. Okay. Let us draw the diagram. 10 identical cells. Right? So these are connected in series. An ideal voltmeter connected across 3 cells. Okay. Ideal voltmeter connected across 3 cells. Okay. Here it is E, E, E. Internal resistance R, R and R. We'll read. Okay. So here an ideal voltmeter connected across the 3 cells. Okay. What is the reading of the voltmeter? Okay. So what is the current flowing through the circuit, or current flowing through the 10 cells, right? So current I equal to, here there are 10 cells, right? So 10 into E divided by 10 internal resistor. So 10 into R. So 10 will get cancelled. I equal to E divided by R. So this is current flowing through the 10 cells, right? Okay. So now what is the current flowing through these 3 cells? Same, I only, right? Current flowing through these 3 cells is I only, right? Okay. So we need to find the reading of the voltmeter, right? That is potential difference across these 3 cells. So potential difference across these 3 cells, V, is equal to, here the current flowing through these 3 cells, that is I, into total resistance. What is the total resistance? 3R. So 3R, right? What is I? I is E by R, right? So V equal to E divided by R into 3R. So R will get cancelled. V equal to 3E. Okay. So the correct option is D. Yeah. Next question. Question number 8. In an atom, electron revolve around the nucleus along a path of radius 0.72 angstrom, making 9.4 into 10 to the power minus 18 revolutions per second. That is the frequency, right? So frequency of the electron is 9.4 into 10 to the power 18 hertz, that is revolution per second, right? The equivalent current is, we need to find the equivalent current, isn't it? So charge of the electron is given 1.6 into 10 to the power minus 19 coulomb. Okay, so we know that current I equal to Q divided by T. So what is Q? Q is charge, right? T is time, isn't it? So Q is equal to E. So I equal to E divided by T, right? So what is 1 by T? 1 by T is frequency, right? So I equal to E into F, right? E into F, isn't it? So now substitute the values. I equal to E is here 1.6 into 10 to the power minus 19 into F is 9.4 into 10 to the power 18. Okay, so now solve this. Okay, so I equal to, you will get 1.5 ampere. So the correct option is D. Okay, 1.5 ampere. Okay, so next question, question number 9. When a metal conductor connected to left gap of a meter bridge is heated, the balancing point. Okay, so everybody knows the meter bridge, right? Isn't it? I don't need to draw the diagram and all, right? So what is the formula for meter bridge? Here the meter bridge R2 divided by R1 to find the resistance. Okay, R2 divided by R1 is equal to here L divided by 100 minus L, right? L divided by 100 minus L. So here meter bridge is heated, that is the wire is heated, right? So wire is made up of conductor, right? Isn't it? So if the conductor is heated, what happens? Resistance will be increases, right? So left gap of the meter bridge is heated, right? That is resistance increased, right? Isn't it? So resistance R2 increased, isn't it? Or R is increased. Resistance increased, right? Here the resistance R increased, isn't it? So if resistance increases, what happens? The balance point will shift towards right, isn't it? So this is the meter bridge, right? Okay, I will draw it only here. Meter bridge, right? So here this is the resistor, right? I am drawing half of the diagram only, okay? Half diagram, right? Resistor R1, right? Here this is the variable resistor, right? Isn't it? So R2, here this is the jockey, right? Here this is galvanometer, this is jockey J and galvanometer. So if left side of the meter bridge if left side of the meter bridge heated, what happens? Resistance will be increases, right? Resistance will increases. So because of that, the jockey, that is null point, will move towards right, isn't it? Null point will move towards right or shifts toward right. So the correct option is B. Okay. Next question, question number 10. A charged particle is moving in an electric field 3 into 10 to the power minus 10 volt per meter with mobility 2.5 into 10 to the power 6 meter square per volt second. Its drift velocity is, the direct question, right? We know the formula for mobility, or we know mobility. Mobility is the ratio of the drift velocity of the electron to the applied electric field E. Now mu, so we need to find the value of Vd. So Vd is equal to mu into E, right? Mu into E. Then Vd is equal to mu is 2.5 into 10 to the power 6 and E is 3 into 10 to the power minus 10. So now solve this, you will get Vd equal to 7.5 into 10 to the power minus 4 meter per second. This is the drift velocity. So the correct option is B. Okay, yeah. Next question, question number 11. Wire bound resistors are made by. Okay, wire bound resistors are made by. So this is the direct question and memory based question. These wire bound resistors are made by manganene. Okay, manganene, constantan, okay, constantan, and nichrome. Okay, and nichrome. So why they are using alloy of manganene, constantan, and nichrome? Because they are insensitive their resistivity, okay, their resistivity insensitive to the temperature. Okay, insensitive to the temperature, that is, if you increase or decrease the temperature, okay, so the resistivity won't change, right? So you know the formula of the temperature dependent on resistivity, right? Temperature dependent on resistivity, rho T equal to rho naught into 1 plus alpha into delta T, right? So if you change the temperature, resistivity changes, right? Here these three alloys insensitive to the temperature, their resistivity insensitive to the temperature, okay? So that's why they are using these three alloys. So option C is the correct answer. Next question, question number 12. If voltage across a bulb rated 200 volt 100 watt drops by 25% of its rated value, the percentage of the rated value which the power would decrease is. Okay, so we know that power P is equal to V square divided by R. Does R is changing? No, right? So what is the percentage change in power? So percentage change in power is equal to P delta P divided by P into 100%, right? Which is equal to 2 delta V divided by V into 100%, isn't it? So read the question carefully. If voltage across a bulb rated 220 volt 100 watt drops by 2.5%, that is, voltage drops by 2.5% of its rated value, right? That is, delta V by V into 100% is 2.5%. Now drops in power in percentage, okay, delta P divided by P into 100% is equal to 2 into 2.5%. Now solve this, you will get 5%, right? So the correct option is A, okay? This is the percentage drop in power. So option A is the correct answer. Okay, next question, question number 13. A wire of a certain material is stretched slowly by 10%. Okay, so initial wire of the length is L. Now it is stretched by 10%, right? So new length L dash is equal to here L initial length plus increased length, right? So it is 10%, that is 0.1 times L. 10 by 100 is 0.1, so 0.1 times L. So new length L dash equal to 1.1 times L. Its new resistance and specific resistance becomes respectively. Option A says 1.21 times, same. See, anyway, specific resistance is same. Okay, if you increase the length or decrease the length, so specific resistance does not change. Okay, if you increase or decrease the temperature, specific resistance will change, right? So here, anyway, option B and D are eliminated, right? Okay, so by saying looking the option only, you can say here, if you increase the length, definitely the resistance will change, right? Resistance, it is depends on the length of the conductor, right? So option C is wrong. Okay, anyway, option C is wrong. Option A is the correct answer. Okay, option A is correct. Okay, let's find the new resistance. Okay, here we know that resistance R equal to rho L by A, right? So now multiply and divided by L. Now resistance R is equal to rho into L square divided by A, right? L square divided by V, A into L, right? A into L. A into L is volume of the wire or the conductor. So if you stretch the wire, the volume of the wire remains same, right? Isn't it? Volume of the wire remains same. If you stretch the wire, area of the cross section decreases, right? Isn't it? So if you compare the initial volume and final volume, both are same, right? So from this I can conclude that R is directly proportional to L square, right? That's it. Now solve. R2 divided by R1. R1 is R, which is equal to here, okay, R2 is R dash. Okay, R2 is R dash. R dash divided by R is equal to L dash square divided by L square. Now R dash is equal to L dash square is 1.1, right? 1.1 L squared divided by L square. L square will get cancelled into R. Okay, so R dash is equal to 1.21 times R. So the correct option is A, right? Okay, next question. Question number 14. A wire of resistance 3 ohm is stretched to twice its original length. The resistance of the new wire will be. We know that here, okay, in previous question only, we have concluded that R is directly proportional to L square. Okay, so R dash divided by R is equal to L dash squared divided by L. Now the length of the here wire is doubled, right? So R dash is equal to 2L square. L dash is 2L, right? So 2L square is 4L square. So 4, this is L square, okay? 4L square divided by L square. L square will get cancelled, right? So R dash is equal to 4 times R. So the correct option is here, okay, 4 times R. The resistance is given, right? Okay, R dash is equal to 4 into 3, which is 12, right? R dash is equal to 12 ohm. So the correct option is here D. Okay, yeah. Next question. Question number 15. In the given arrangement of experiment on meter bridge, if AD corresponding to null deflection of the galvanometer, see here, this is galvanometer, right? Here AD corresponding to null deflection of the galvanometer is X, okay, is X. What would be its value if the radius of the wire AB is doubled? Okay, here if the radius of the AB is doubled, what would be its value, right? So here we know that for meter bridge, here R2 divided by R1 is equal to X divided by 100 minus X. Does resistance here depends on here this formula, in this formula the radius term is there? No, right? So if you increase the radius or decrease the radius, the resistance does not change, okay? Resistance will not change. So resistance here, the deflection, the null deflection shows same value only, that is X only, okay? It's same, that is X, right? So the correct option is A. Okay, yeah. Next question, question number 16. A copper wire of length 1 meter, uniform cross-sectional area 5 into 10 to the power minus 7 meters square, carries a current of 1 ampere, assuming that there are 8 into 10 to the power 28 free electrons per meter cube in copper. How long will an electron take to drift from one end of the wire to the other? Okay, so this is the copper wire, right? The length of the copper wire is 1 meter, right? And then area of the cross section 5 into 10 to the power minus 7 meters squared. So this is area of cross section, length L, right? The number density, that is the value of N, is equal to 8 into 10 to the power 28, right? Electrons per meter cube, isn't it? So we need to find the time t, that is how long or what is the time taken by the electron to drift from one end of the wire to the other, right? Okay, what is the drift velocity of the electron? Drift velocity of the electron is Vd, right? Vd is equal to the length of the wire L divided by time t. So we need to find t, right? So t equal to L divided by Vd. So we know the value of L, right? But we don't know the value of Vd, that is drift velocity, right? So drift velocity Vd is equal to I divided by N into E into A, right? I divided by NE A, isn't it? This is the relationship between drift velocity and current I. So now substitute Vd to this expression. Now T is equal to, so substitute Vd expression to this expression, you will get NE A L divided by I. So T equal to N is here 8 into 10 to the power 28, right, into E. E is here what is the value of E, that is charge of the electron, 1.6 into 10 to the power minus 19, right, into A is 5 into 10 to the power minus 7 meter squared, right, into L is 1 meter divided by I is 1 ampere. Now solve this, you will get T is equal to here T is equal to 6.4 into 10 to the power 3 second. So the correct option is D. Okay, 6.4 into 10 to the power 3 second. Here 1.6 into 5 is 8, 8 into 8 is 64, right? So 64 into 10 to the power 2, right? So that is 6.4 into 10 to the power 3 seconds. Yeah, next question, question number 17. Consider an electrical conductor connected across a potential difference V. Let delta Q be a small charge moving through it in time delta T, if I is the electric current through it. The first statement, the kinetic energy of the charge increases by I into V into delta T. Correct, right? Isn't it? So when when charge moves through the potential difference, that is higher potential to lower potential, right? Isn't it? Charge moves through here higher potential to lower potential, isn't it? Charge moves from higher to lower, higher potential to lower potential, right? When charge moves from higher potential to lower potential, potential energy decreases, right? Isn't it? Potential energy of the charge decreases by I into V into delta T, right? If potential energy decreases, then kinetic energy of the charge increases, right? Kinetic energy of the charge increases by IV delta T, right? IV delta T. So the first statement is correct. The second statement, the electric potential energy of the charge decreases by delta T, correct, right? The third statement, the thermal energy of the conductor increased by, right? So what is the meaning of thermal energy? Thermal energy is nothing but kinetic energy of the electron, right? Isn't it? Kinetic energy of when you heat the metal, what happens? The charge gains energy, right? It will start to move, right? Or it will start to vibrate, right? Isn't it? Or it will start to move. So here, so the thermal energy or energy gained by the heat, right? Isn't it? That is I into V into delta T. That is kinetic energy of the charge, right? I into V into delta T. So this one is also correct. So the first option is correct. A is 1, 2, 3. Okay. Yeah. Next question. Question number 18. A metal rod of length 10 centimeter and a rectangular cross section of 1 centimeter into half centimeter is connected to a battery across opposite faces. The resistance will be. Okay, let us draw the diagram. Okay. Here. So this is the metallic conductor, right? The length is 10 centimeter, right? Breadth is 1 centimeter, isn't it? This is 1 centimeter and the height is half centimeter, isn't it? Okay, the resistance will be maximum when the battery is connected across 10 centimeter into 1 centimeter faces. Okay, we know that resistance R equal to rho into L divided by A. To get maximum resistance, L has to be maximum, area has to be minimum, right? L has to be maximum, area has to be minimum. So here area will be 10 centimeter square, right? Isn't it? Right? But length is minimum, it will be 1 centimeter only, right? So option A is wrong. Okay, let's see. Option B, same irrespective of the three faces, wrong. Okay, Option C, maximum when the battery is connected across 1 centimeter into half centimeter phases. Correct, right? When the battery connected across 1 centimeter into half centimeter phases, here the area will become half centimeter square, half centimeter squared, right? And the length is 10 centimeter. Length is maximum, area is minimum, right? So option C is mostly correct. Let's see option D, maximum where the battery is connected across 10 centimeter into half centimeter. Okay, 10 centimeter into half centimeter. See here, the area is smaller, right? Area is smaller compared to the C, right? So option D is wrong, option A is wrong, so the correct option is C. Okay, next question, question number 19. A car has a fresh storage battery of EMF 12 volt and the internal resistance 2 into 10 to the power minus 2 ohm. If the starter motor draws a current of 80 ampere, then the terminal voltage when the starter is on is. Okay, we know that terminal voltage V equal to EMF of the battery E minus I into R. R is the internal resistance of the battery, right? So V equal to E is 12 volt minus I is 80 ampere. Okay, 80 into 2 into 10 to the power minus 2 volt, right? 80 into 2 is 160, 160 into 10 to the power minus 2 is 1.6. So V equal to 12 minus 1.6. So V equal to 10.4 volt. Okay, so the correct option is A. Okay, correct option is A. Next question, question number 20. Each resistance in the given cubical network has resistance of 1 ohm. Okay, so here it's 1 ohm. Okay, 1 ohm, 1 ohm. Here this will also be 1 ohm, 1 ohm. Okay, 1 ohm, 1 ohm, 1 ohm, 1 ohm, 1 ohm, 1 ohm. Okay, and equivalent resistance between A and B. We need to find equivalent resistance between A and B. See, these kind of questions are asked in every exam. Okay, in CET, JEE Main, okay, every exam, VIT, BITS, every exam. Okay, so listen carefully. So they may ask this kind of question. So here the current entering to this circuit is 3I. Okay, here the resistance are same, right? 1 ohm, 1 ohm, 1 ohm, right? So at this point the current will divide, right? Current will divide equally, that is I ampere. Okay, here I ampere, here I ampere, right? So now at this point again current will divide equally. The current I ampere will divide equally, that is I by 2, here I by 2, right? Now at this point current will divide equally, I by 2 and I by 2, right? And then at this point current will divide equally, I by 2 and I by 2, right? Now at this point here I by 2 and I by 2 will join, right? Isn't it? It will add, isn't it? I by 2 will add. Now current flowing through this resistor is I, right? And then here at this point I by 2 and I by 2 will add. So current flowing through this resistor is I, right? And at this point these two I by 2 and I by 2 will add, these two I by 2 will add. So the current flowing through this resistor is I. Now at this point the total current will be I, right? Okay, so here this resistor, this resistor, this resistor, right? These three resistors has 1 ohm, right? 1 ohm resistance, right? So the current is same, right? So potential difference across each resistor will be same, right? Potential difference across each resistor will be same. So now I can redraw this diagram as here point A, okay, point A, right? Potential difference across each resistor is same, that is these three are in parallel, right? In parallel potential difference across each resistors are same, right? So 1 ohm, 1 ohm and 1 ohm, right? So now there are 6 I by 2s, right? Isn't it? There are 6 resistors and current through that resistor, those resistors are I by 2, right? So the potential difference across each resistors is same, right? So all 6 resistors are in parallel, but it is in series with these 3 resistors, right? Isn't it? So this will be 1 ohm, 1 ohm, 1 ohm, 1 ohm, right? 1 ohm and 1 ohm. All of them are in series, sorry, parallel, right? Then again, these three resistors, that is 1 ohm, 1 ohm and 1 ohm. These three resistors are in parallel because potential difference across each resistors are same. So this is the new circuit diagram, right? So here 1 ohm, okay, 1 ohm, 1 ohm, 1 ohm, 1 ohm, right? So there are total 18, 12 resistors, right? Okay, 6 plus 6, 12. Now, what is the equivalent resistance of these three resistors, parallel resistors, right? So that will be 1 by 3, 1 by 3, and here 1 by 6, right? So we are finding R equivalent, right? R equivalent is equal to 1 by 3 plus 1 by 6 plus 1 by 3, right? So now R equivalent is equal to 2 by 3 plus 1 by 6, right? R equivalent is equal to, here 2 by 3 plus 1 by 6 is 5 by 12, right? So this will be into 2, 5 by 6, okay, 5 by 6 ohm. So the correct option is C, okay. And then another thing, so you have to solve here these two points here, the point A and B, okay, point A and B, these 2 points, okay, these 2 points, so you need to find the potential difference across these 2 points A and B, sorry, equivalent resistance between A and B, okay, equivalent resistance between A and B, okay. Solve this and write the answer, okay, in comment box. Yeah, next question. Question number 21. A potentiometer has a uniform wire of length 5 meter and a battery of EMF 10 volt. Negligible internal resistance is connected between ends. A secondary cell connected to circuit given balancing length of 200 centimeter. The EMF of the secondary cell is, okay, for potentiometer we know that the potential gradient, right? From the potential gradient here, E2 divided by E1 is equal to L2 divided by L1 because E is equal to K into L, right? K is potential gradient, right? E2 by E1 is equal to L2 by L1, right? So here we need to find the value of E2, right? E1 is 10 into L2, right? L2 is 200 centimeter, that is 2 meter. Sorry, this is equal to 2 meter divided by L1 is 5 meter. So meter will get cancelled. So E2 is equal to, here 5 2s are 10. So this will be 4 volt. So the correct option is C. Okay. Next question. Question number 22. The color code of a carbon resistor of resistance 0.28 kilo ohm plus or minus 10 plus or minus 10% is, okay. So here I can write 0.28 kilo ohm as 28 into 10, right? 28 into 10, isn't it? So 0.28 kilo, that is 0.28 into 10 to the power 3, right? 0.28 into 10 to the power 3 is 280. 280 I can write as 28 into 10. Here plus or minus 10% tolerance, right? So for red, here the number is 2, right? And then for gray, it's 8, right? Then for brown, it's 10. For silver, the tolerance is 10%, plus or minus 10%. Okay, red, gray, brown, and silver. So option A says red, gray, silver, silver, wrong. Option B says red, green, wrong. Option C says red, gray, brown, silver, correct. Option D says red, green, wrong. Red, gray, right? Yeah. Next question, question number 23. IV characteristic of a copper wire of length L and area of cross section A is shown in figure. The slope of the curve becomes. Here this is the I versus V graph, right? So the slope of the curve I divided by V is equal to 1 by R. So 1 by R is the slope, right? Okay, 1 by R is the slope. So option A says less if the area of the wire is increased. Okay, so here I can write 1 by R as A divided by rho into L. Okay, A divided by rho into L. So if area increased, area of the cross section increased, then the slope will increase, right? 1 by R value will increase, slope will increase, not will decrease. Okay, so slope will be, the curve becomes more if the area of the wire is increased. So it is more. Okay, or large. So option A is wrong. Option B, less if the length of the wire is increased. Correct. If the length of the wire increases, the slope becomes lesser. If length of the wire increases, slope becomes lesser. So option B is correct. Option C, more if experiment is performed at the higher temperature. Wrong, right? So here the temperature dependent on resistivity R equal to R naught into 1 plus alpha into delta T. Okay, so the curve is different for different material. For conductor it is different, for semiconductor it is different, right? So option C is wrong. You will not get straight line, okay, if you perform the experiment in higher temperature. Option D, more if a wire steel of same dimension is used. Wrong, right? So the correct option is B. Next question, question number 24. Though the electron drift velocity is small and electron charge is very small, a conductor can vary an appreciably large current because. Option A says electron number density depends on the temperature. Wrong. Electron number density depends on the material. Okay, so we know that drift velocity Vd is equal to I divided by NEA, right? So the current I equal to NEA Vd, right? Isn't it? So here the conductor can carry an appreciably large current because of the large or higher value of the electron number density. Okay, higher value of the electron number density. So B, electron number density is very large. Correct. Option C says relaxation time is small. Wrong. Option D says drift velocity of the electron is very large. Wrong. So the correct option is B. Okay. Question number 25. Masses of the three wires of copper are in the ratio 1:3:5. That is M1 is to M2 is to M3 equal to 1:3:5. Okay, and their lengths are in the ratio 5:3:1. Lengths are in the ratio 5:3:1. That is L1 is to L2 is to L3 is equal to 5:3:1. The ratio of their electrical resistance R. Okay, we need to find the resistance ratio R1 is to R2 is to R3, right? So we know that electrical resistance R equal to rho L divided by A, right? So now multiply and divided by L. Now we will get R equal to rho L square divided by V, rho L square divided by V. What is V? V is volume, right? Volume of the copper, isn't it? Volume of the copper wire, okay, or copper, right? Okay, copper wire. So volume V equal to mass divided by density D, right? Usually density represented by rho, represented as rho, okay, but here I have used rho for specific resistance, or here R used as a resistivity, right? isn't it? Rho used as a resistivity, right? So now R is equal to here rho L square divided by m by d. That is R equal to rho L square d divided by m. Here rho and d both are constant, right? Specific resistance or resistivity and density both are constant. So R is directly proportional to L square divided by m, right? So R1 is to R2 is to R3 is L1 square divided by m1 is to L2 square divided by m2 is to L3 square divided by m3. Okay, so now R1 is to R2 is to R3 is equal to L1 square by m1, right? That is 5 square divided by 1. 5 square divided by 1 is 25 only, is to then L2 square by m2, that is 9 by 3. 9 by 3 is 3, is to L3 square by m3, that is 1 by 5. Now solve this, okay? You will get R1 is to R2 is to R3 equal to 25 is to 15, 125 is to 15 is to 1. Okay, 125 is to 15 is to 1. So the correct option is C. Okay, correct option is C. Next question, question number 26. The effective resistance between P and Q for the following network. Okay, we need to find the effective resistance or net resistance between P and Q, right? So here 3 ohm and 3 ohm, these two resistors are in series, right? So what is the net resistance here? So this will be 6 ohm, right? So now 6 ohm is in parallel with 6 ohm, right? So 1 by R dash is equal to 1 by 6 plus 1 by 6. So R dash is equal to 3 ohm, right? Now the whole thing here, this will be 3 ohm, right? So now this 3 ohm is in series with 4 ohm and 5 ohm, right? So the effective resistance between P and Q is equal to 4 plus 3 plus 5. So R effective between PQ is equal to 4 plus 3 7 plus 5 is 12. So 12 ohm. So the correct option is here C. Okay, 12. Next question, question number 27. The Kirchhoff junction rule is a reflection of. Simple direct question. Okay, Kirchhoff's junction rule is a reflection of conservation of charge. Okay, conservation of charges. Okay, so what is Kirchhoff junction rule? Here the current entering to this junction, okay, the sum of the current entering to the junction is equal to current flowing out of that junction, right? The sum of current entering into this junction, okay, so this is the total current I, is equal to the current flowing out of that junction, right? Isn't it? That is, net current at this junction is equal to 0. Okay, so that is the conservation of charge, right? Current is nothing but rate of flow of charge, right? So the Kirchhoff junction rule is a reflection of conservation of charges. Yeah. Next question. Option C is the correct answer. Okay. Question number 28. The variation of terminal potential difference V with current flowing through cell as shown. The EMF and internal resistance of the cell are. Okay, we need to find EMF and internal resistance of the cell using this graph. Okay. So here when current is 0, okay, when I equal to 0, so what is the EMF of the cell? EMF of the cell is 3 volt, right? 3 volt, isn't it? When current is 0, EMF of the cell is 3 volt, right? So when voltage is 0, current I equal to 6 ampere, right? When voltage is 0, current I equal to 6 ampere, right? Isn't it? So here internal resistance R equal to here E divided by I, right? So R equal to E is 3 volt divided by I, that is 6 ampere, which is equal to 0.5 ohm, right? 0.5 ohm. So here the terminal potential difference V is 3 volt, right? Terminal potential difference V is 3 volt, isn't it? 3 volt, and internal resistance 0.5 R. So the correct option is D, 3 volt and 0.5 R, 0.5 ohm. Okay. Next question, question number 29. In a potentiometer experiment, the balancing point with a cell at a length 240 centimeter. Here L2 is 240 centimeter. Okay. On shunting, the cell is with the resistance of 2 ohm, R equal to 2 ohm. Balancing length becomes 120 centimeter, that is L1 equal to 120 centimeter. The internal resistance of the cell is, okay. So this is direct question. You can solve this question. I mean, you don't need to draw the diagram and all, okay? Potentiometer diagram, okay? You know the formula, right? Internal resistance of the cell R equal to R into here L2 divided by L1 minus 1, right? So R is equal to R is 2 ohm, L2 is 240, L1 is 120 minus 1, right? So this will be 2, 2 minus 1 is 2, 2 minus 1 is 1, R equal to 1 into 2 is 2 ohm. So the correct option is D, okay, D. Next question, question number 30. Ohm's law is applicable to. So Ohm's law is applicable to ohmic devices, okay. So that is, if you draw current V versus I graph, you will get linear, okay, linear graph, okay, understood. So it is applicable to the conductors, okay, conductors, not for diode, transistor and electrolyte, okay. These are not ohmic devices, okay, these are not ohmic devices. So conductor is an ohmic device, so option D is the correct answer, okay. Yeah, this is the last question, right? We are done. So thank you so much for watching this video. If you love this video, please like and share, and if you want to watch more such videos, please subscribe. And I have given you the homework, right? You have to find the effective resistance between point A and B. I have changed the point, right? So please write the answer in comment box. Thank you so much.